If the limit of the function minus 8 over x minus 1 is equal to 10 as x is approaching 1, we want to find the limit of the function when x is approaching 1. So the first thing we're going to do is we're going to start out with the numerator here, where the limit as x approaches 1 of f of x minus 8. Okay, so if we wanted to then rewrite this so that we have a denominator of x minus 1, that means that we would have to multiply both the numerator by x minus 1 and the denominator by x minus 1. So then what we would get is the limit as x approaches 1 of f of x minus 8 over x minus 1 times x minus 1. And now you can see how this part here is resembling this part here. And all we did was multiply this by 1, which we can do. And so now let's apply the limit rule, where we're going to use the limit for the first one and the second one. So that means that we get the limit as x approaches 1 of f of x minus 8 over x minus 1 times the limit as x approaches 1 of x minus 1. So if we take a look up here, we know that this entire limit is equal to 10. So we can replace this entire thing with 10. So let's go ahead and do that. So we know this is equal to 10 times, well, if we put 1 in for x, 1 minus 1 is going to give us 0. So therefore, this answer is going to give us 0. So what that tells us is that from the very beginning, we know that the limit as x approaches 1 of f of x minus 8 is equal to 0. Now, let's continue then. Thus, if we look at this statement here, the limit as x approaches 1 of f of x can also be written as the following. Well, we can rewrite this by writing, okay, well, the limit as x is approaching 1, okay, we can add an 8 and subtract an 8 to this function, which is what we have in step number 4 as part of it. So we can say, okay, well, this is the limit of f of x minus 8, and then making that 0, we can add an 8. Now again, we can do that because technically we're adding 0 to f of x because negative 8 plus 8 is 0. So now what we're dealing with is we can now distribute that limit as x is approaching 1 of f of x minus 8 and then plus the limit as x is approaching 8 of 8. So from step number 4, we know that the limit of f of x minus 8 as x approaches 1 is 0. So we can replace this entire limit with the 0. And then this gives us a constant of 8. So that is equal to 8. So we can say then that the limit as x approaches 1 of f of x is equal to 8. And then let's make one final note here. Okay, the note is very important here. It says, note that the value of the limit as x approaches 1 of f of x minus 8 over x minus 1 does not affect the answer since it's multiplied by 0. What's important is that the limit as x approaches 1 of f of x minus 8 over x minus 1 exists.